Okay, so product and chain with fractional exponents or even negative fractional exponents. Let's say 3x minus 2 to the 1/3 times 5x squared minus 4 to the 3/4. So still under the same type. So it's still product and chain. We're going to get negative exponents. We're going to have to get a common denominator, add them up. It's the same process as yesterday, it just looks different because you got fractions involved. So 2d1, so the second thing, times the derivative of the first thing, which is chain rule. So you're bringing down the 1/3, you're leaving the little guy alone, you're reducing the power by 1, and you're remembering to multiply by the derivative of the little guy. So the second thing times the derivative of the first thing plus the first thing, so I'm just rewriting that, times the derivative of the second thing. So bring it down to 3/4, leaving the little guy alone, reducing the power by 1, so it's negative 1/4, and remembering to multiply by the derivative of the little guy. Questions on that stuff? So now I gotta start repositioning things, and I've got a couple other things going on here too. A new thing that didn't happen yesterday is I got this fraction here. So typically I just grab that fraction and use that to start the fraction I'm gonna have to put everything into. In this case, I'm gonna have that 1/3 go there, and I'm gonna have that 3 go on top. So what can I do with those? So I can just cancel them out and just say, okay, pretend they're gone, right? I mean, basically, what's 1/3 times 3? 1, so I don't need to worry about it. But then I'm going to have this 5x squared minus 4 on top because that exponent's positive. And I'm going to have the 3x minus 2 on the bottom and make that exponent positive because I flipped it down. And then leave some space because we got to do some adjusting. Let's go to the other. So again, I'm going to grab that fraction and use that to split to start my fraction off. We got 10x on the top. I've got a 3x minus 2 to the 1/3 on top. And then I've got this 5x squared minus 4 on the bottom, and now that'll be to the 1/4. You guys with me? Questions on up to there? So now I need a common denominator. What's my common denominator?
Sorry.
So if you think about a simpler version of it, if I had like if I had like 1 over x here, and then 1 over 4y there, what would my common denominator be? 4xy, right? Or 4yx. So I need to put 4 and a y here, and then therefore on top. And an x here, and then therefore on top. So that's the same idea that we're going to do. Our common denominator is going to be 4 times this to the 1/4 times this to the 2/3. So we're going to need like all 3 parts in there. So what's the only thing I need over here? Is the 3x minus 2 to the 2/3, right? Basically, I want all 3 of those on the bottom of both of these. So I'm going to put 3x minus 2 to the 2/3 on the bottom over here, so it's going to match up with this. And I'll fix this one in a second. But if I do it to the bottom, what do I have to do? I have to do it to the top. And now this is going to happen every time just because of the way these are set up. It's not as bad as you think because when I combine those, how many 3x minus 2's do I have? 1. And that'll work every time. That's just how the pattern will kind of go. You can add those up, and then there won't be a fraction exponent on top anymore. So on this side, I need 2 things. I need the 4, first of all, because there's a 4 over there. So I need to put a 4 on the bottom. But if I put it on the bottom, I got to put it on the top. minus 4, how many of them? 1/4. So I'm going to put 1/4 of them on top also, but, again, when I combine those, how many 5x squared minus 4s do I really have? Just 1. So the fractions on top clear out. Good. So, I just take a step and simplify that. It gets annoying writing the bottom over and over again. And so here I'm going to go, okay, that's 30x times 3x minus 2. Questions to there? I'm kind of running out of room in my window here. But all you have left to do is distribute there, which will give me 20x squared minus 16. Distribute there, which will give me 90x squared minus 60x. And you're going to take those things on top and combine them and then rewrite that little bottom guy again. So I should have 110x squared minus 60x minus 16 over, and I'm out of room, so I'm just going to say like over that same stuff. But you'd have to rewrite that bottom again. Questions on there? Where'd you get this from? I think you screwed up this. Why did you do this? Anything? I don't know. Your hand's tired from one problem.
Yeah.
Alright, shit.
My writing hand isn't very in shape. I had to exercise it a little more.
We'll work on that for you.
Do you have to distribute the bottom?
What do you mean? Like the bottom, you're just going to take this and rewrite it. You can't distribute. Do you want to put the 4 through? Is that what you're saying?
Yeah.
So when you go to simplify, what do you do first? Exponents or multiplication? Exponents. So you can't multiply until the exponents are done. And there's no way to be done with those, so you just use it. Other questions? Wait, I didn't say it like that.
I said,
Okay. So again, like they might, what could they do here? So like, they can take a 2 out, which they might not, but just, you don't have to, but again, recognize that they might. Other questions here?
how would you, just out of curiosity, how would you write like 3x minus 2 to the 2/3 power? Like, how would you rewrite it as like a square root?
As like a radical, so it's always inside on top, outside of the bottom, so that'd be the 3rd root of 3x minus 2 squared.
Oh. Oh, yeah.
Okay. Yeah. Okay, so let me give you one to do. Raise. So the first thing I would do is just erase this or rewrite it. As x squared minus 4 to the 2/3. And then I'm taking my product rule and quotient rule. So the second thing times the derivative of the first thing, which is bring down the half, leave the 4x minus 3 alone, reduce the power by 1, and multiply by 4. I think that's the easiest part to forget, is that, like, multiply by the derivative of the little guy. So that's 2d1 plus 1. d2, so bring it down 2/3. Leave the inside alone, reduce the power by 1, and then don't forget to multiply by 2x. So, over here, I think it's easiest to do this right now. What's half times 4? Is 2, so I can just leave that as 2. You could have also gone like 1/2, put a 4 there, but at that point you hopefully go, okay, 4/2 is 2, and get to it just a different way. This x squared minus 4 stays on top. The 4x minus 3 goes to the bottom. Over here, I got this 2/3. I'm going to put 2 on top and a 3 on the bottom. I'm also going to put a 2x on top, so I'm just going to rewrite that as 4x over 3 right now. Is that okay what I did there? Okay. And then this 4x minus 3 to the 1/2 goes on top, and the x squared minus 4 to the 1/3 goes in the bottom. So now you're looking at, you need a common denominator. So I'm going to start multiplying my stuff. So I'm going to do that 3 first. I need a 3 over here. So that's easy for me to just write a 3 there. And I would just cross that off and write a 6. Let's do that 3 is 6. And then I also need an x squared minus 4 over here. So the 1/3. I need that piece to be here. If I do that, I got to write it on top also. And this is kind of a clue that you're on the right track, because when you combine those, you're going to get 1. And over here, I need 4x minus 3 to the 1/2. I need to take the piece over here. If I put it on the bottom, I got to put it on top also. And again, I'll have exactly 1 of those. So I get 6 times x squared minus 4 to the first on top, and then that. Is it okay if I don't write the bottom over and over again? Yeah, it's fine. Just do
What happened to the 1/2?
this.
Yes.
I multiplied it by 4. I got 2. And then I multiplied it by 3 from this thing and got up to 6. With me? So it's 6 times x squared minus 4 all over, that stuff. Over here I get 4x times 4x minus 3 to the first all over the same stuff. You're going to distribute, so this will give you 6x squared minus 24. This will give you 16x squared minus 12x. So you're going to end up with 22x squared minus 12x minus 24 over all that stuff from before. That's your answer. Hopefully I got it. Did you guys get that? What?
Yeah, eventually.
Okay. Yeah.
What I did is do the 1/2, and then multiply the top by 4.
1/2.
I put it in fraction form before I multiplied the total.
Okay, so you got a 2 on the bottom and 4 on top?
Yeah.
So then with the 2 and the 3, you'd have to get a common denominator with those and make them both 6.
Yeah, that's what I did.
So you put a 3 here and a 2 here. So probably what ends up happening here is you just have, do you have a 6 there?
Yeah.
So then everything on top should just be double what mine is. And that's totally fine. That's a legit answer. The multiple choice, they might write it different, at which point you'd have to realize how it matched, but yours is good. Other questions here?
I just forgot the whole 1/2 thing with the 4x.
Oh, you're good?
Yeah, I'm good.
Okay, let's do this. Can I erase? So, write this down. So we're going to do quotient rule, then chain rule. This is my notes for this. Avoid at all costs. Quotient rule and chain rule together can result in fractional exponents on top of fractional exponents within another fraction. It just gets insane. Because quotient rule itself forces you to have a fraction, right? Well, then if you start taking derivatives, those turn into fractions, and you get fractions on top of fractions. It's a mess. So, how do we fix it? So let's say I gave you, 4x minus 1 over the square root of x squared plus 3. And I said take the derivative. Well, it looks like quotient rule. You are welcome to do quotient rule. Don't ask me for help with it though, because I'm going to be like, no, I told you to avoid this. So, what I would want you to do is rewrite it. What power is this on the bottom? What power is it on the bottom? Is a 1/2. So I'm going to bring it up and rewrite it on top. So now what's the power? Negative 1/2. And then we're doing product rule and chain. So we want to avoid quotient and chain. It's like the dumb. So you turn it into product and chain. You bring it up, and then you're going to do that. Let's actually do that problem because that's a little different than what we did. So I'll give you guys a second to try that, and then I'll go through it. All right. So your derivative. Second thing. Times the derivative of the first thing, which is just 4. It's really nice at this point because we have all those chain rules. Plus the first thing times the derivative of the second thing. So negative 1/2. Leave the little guy alone. Reduce the power by 1 makes it negative 3/2, and then times the derivative of the inside, so don't forget that 2x. I rewrite those as fractions. Putting the x squared plus 3 to the 1/2 on the bottom here. And over here, I'm going to have a 1/2 and a 2x, but I think it's easiest for me to just address those right now and say, what's 1/2 times 2x? Just x. And then a 4x minus 1 on top. And an x squared plus 3 to the 3/2 on the bottom. So some of you might have put like a 2x there and a 2 down there. That's totally fine. You can work with that, or you can cancel. Like you can do the problem with the 2 there, or you can reduce, cancel, and then do the problem. Doesn't matter. Yeah. Oh, it's a negative 1/2, isn't it? Yeah, thank you. I forgot that was a negative there.
Would it be okay, like, if you didn't do that? Like, what if you just left it as is?
Did more people just leave it? Should I do it that way? So, you could do this, because that'd be like taking the negative 1/2 and going negative on top, 2 on the bottom. And then a 2x, just putting it there. If you do that, you can leave it like it is, and you can, since you got a 2 there, we're going to put a 2 over here, and a 2 on top. And run through the whole thing that way. You can also cancel it out, and then you don't have to worry about putting a 2 over there, because you cancel out over there. Do you prefer me to go through one way or the other? You want it with the 2 down there? Okay. So, if I leave it like this, I need a 2 over there, but then I need to put a 2 on top, so I basically just turn that into an 8. So I multiply the top by 2. And then you've got a common denominator thing that's a little different than the one before. You've got to match up the powers. So I've got 3/2 of these things over here, and I've only got 1/2 of them there. So how many more of them do I need in this one? 2/2, which is just 1, right? Like I need exactly 1 of those to be there, and so I'm going to put 1 of those on the top also. And so if I distribute as I do this, this will be 8x squared plus 24 over all that stuff. This is actually negative 8x squared plus 2x over the same stuff. And so I end up with 2x plus 24 over all that stuff. Oh, just that. 2x is there.
Oh,
The 8x squared's canceled,
okay.
right?
Yeah.
How many had that answer? How many had the answer where, so the other answer, and if you would cancel out the 2's earlier, on the top you'd have x plus 12, and this 2 wouldn't be here. Everybody have that? Okay. And they're both the same. If you get this, you might have to like reduce it in your brain to match up multiple choice wise with what they got. But you can also just look at this and take a 2 out and be like, oh, well, that's just x plus 12 over. Running out of room. You know, that's the same thing.